not all two-term polynomials can be factored using a difference of squares. Like that's something we need to make very up and honest. You are going to get binomials that can't be factored using this. All right, difference of squares is like a very mathematical statement, but we can kind of dissect what it means. So difference in math means subtract. Squares in math means something that's a perfect square. For instance, the number 4, right? 4 is 2 squared. The number 9 is 3 squared, right? That's a perfect square thing. So when you go to factor a two-term polynomial or a binomial, you need to check first to make sure you have a difference, a subtraction question, and perfect squares. So everything in it is a perfect square thing. Looking at this, subtraction side, so that's good. Is a squared a perfect square? That's a hard one, right? We're like, I don't know, exponents, is it a perfect square? If it's even, it's a perfect square. Okay, so it's a to the power 2, a to the power 4, a to the power 6. Anything even is a perfect square letter. Is the number 4 a perfect square? Yeah, 2 squared is 4, right? Awesome. This is a difference of squares. The first thing I had to do was just identify, is this a difference of squares? Since it is, I'm going to use my difference of squares factoring method, which is very, very simple. It is square root everything. So we're just going to go square root that whole thing. When you square root a squared, you get a. Minus, when you square root 4, you get 2. Gorgeous. And I put that in brackets. Now, some people leave their answer like that, and they're just like, oh yeah, I'm good, I square rooted everything. And factoring is unmultiplying, right? We don't have a multiplication here. We just have a minus 2. We got nothing else. So that doesn't make sense to the final answer. So if you think about it that way, you'll remember the trick that there's 2 binomials here. So if I only have 1, then there's some sort of mistake going on. If you also remember, every time we factor, I shouldn't say every time, but most time when we factor, we end up with 2 binomials. The second binomial is the exact same thing as the first binomial, except with a plus symbol in between. So I got a minus 2 and a plus 2. That is your solution. Easy, right? Yeah, it's not that bad. So difference of squares usually is the easiest one if you remember how to do it and you remember how to recognize one. So if you look at B over here, I have a binomial. Okay? I need to check to see if it's a subtraction. It is a subtraction. I need to check to see if I can square root everything. I can square root t squared. I can square root 144. That might not be one you have memorized, but if you try it, it does work. So if you went square root 144, it equals 12. This is a difference of squares. That means I can square root the entire question. That will give me t minus 12. And we know when we factor things, we should always get 2 binomials, not just 1. The other binomial is the exact same, but with a different symbol in between. I'm changing the color so it really stands out that I have 1 positive, 1 negative. Okay, let's do 2 more. So we look at C. You have x squared minus y squared. It's a subtraction. X squared can be square rooted. Y squared can be square rooted. So there's not even any numbers in this question, but I could definitely still use difference of squares because it followed my rules. Subtraction, square rootable, square rootable. So if I look at this, square root the whole thing, it gives me x minus y, x plus y. Awesome. Last one. You could simplify that to be p squared minus 49 if you wanted. You could also just look at it as when I square root 7 squared, it should work because it has an even exponent, right? And the square and the square root will cancel each other out. So it's kind of your choice. If you want to change that to be 49, that's great. If you don't, that's also great. I'm not going to. I'm just going to square root the whole thing. The square root of p squared is p. The square root of 7 squared is 7. Right? The square symbols just cancel out. I always get a second binomial. My second binomial has a plus sign. That's my solution. Fantastic. On the side, I'm just going to take a minute to show you why this actually works, because sometimes people are like, whoa, how does that actually happen? Why is that working? I'm going to show you with the very first one, because that's the easiest one to do it with. So a squared minus 4. We said that if you did difference of squares, it would turn it into a minus 2a plus 2. We could check our work by multiplying this back together and seeing if we get the original equation. All right, so we're going to try that. We're going to try multiplying these two things together. When we multiply them together, I'm going to use distribution. A times A would be a squared. A times positive 2 would be plus 2a. Then I distribute my middle. Negative 2 times a would be negative 2a. Negative 2 times positive 2 would become negative 4. So I multiplied those two binomials together. I got 4 terms. I didn't get 2 terms. I didn't get the original equation. But remember, when you multiply, you usually have like terms somewhere. We have that. We have like terms right there. And you'll notice the complete opposites of each other. You have plus 2a and you have minus 2a. So if you were to combine those, how many a's would you have left? You have 0 a's left. And the only thing remaining would be a squared minus 4, which was the original question. So that's why it works like that. People sometimes get confused about why you have 2 binomials. It's because when you multiply, you do get 4 terms, but they always cancel out. That's why it has to be 1 positive, 1 negative to create that canceling out effect. At the end of the day, you don't need to stress about knowing why it works, because you know that it works. But knowing why sometimes helps. Awesome. We're going to look at a few harder ones, because it does get a little trickier than that. We're going to scroll down past those to these guys. That's example 2. Factor, if possible, using the difference of squares method. All right. Look at A. That's a lot harder than anyone we've seen before. There's extra numbers in there, right? We're not used to that. We're still going to follow our factoring rules. First rule is GCF. Is there a number I could divide into 16 and into 49? Might take you a while to think about it. The answer is no. You couldn't find anything that divides them both. I then count my number of terms. I have 2 terms. That means I'm going to check to see if I can do difference of squares. Do I have a subtraction question? Yes. Can I square root everything? Can I square root 16? Yep. Can I square root t squared? Yeah. Can I square root 49? Yeah. This is a difference of squares. So I can square root the whole thing. I'm going to do every single number and letter individually. The square root of 16 is 4. The square root of t squared is t. The square root of 49 is 7. So that would square root to become 4t minus 7. The other one would be the exact same, but with a plus symbol. So that factor would be 4t minus 7, 4t plus 7. Awesome. We're going to look at B. B is a little tricky because of the second term. So if you look at this, we try GCF, we cannot. We count the number of terms. There's 2. We know 2 terms means difference of squares. Do I have a subtraction question? Yes. Do I have things that are all square rootable? That one's a little bit harder to answer. 81 is square rootable. A squared is square rootable, but is 1 square rootable? And that's one that always throws people off. 1 is a perfect square number. What's 1 squared equal? 1. Right? So 1 times 1 is 1. That means 1 squared is 1. That means 1 is a perfect square. It's just when you square root it, you're going to get 1. So it's not a very exciting perfect square, but it is a perfect square. So when I square root all that, I get 9a minus 1, 9a plus 1. Awesome. Try C and D on your own. You might want to stop at E and F, but give C and D a try. Alright, for C, I tried GCF. I cannot. I count that there's 2 terms. I check to see if it's difference of squares. It's subtraction. Perfect. I can square root 100, and I can square root y squared. If you're ever unsure, just try it. Right? So with letters, it's always even exponents are square rootable. With numbers, just test it. Go square root 100. If it worked, awesome. If it gave you a decimal, it doesn't work. Right? It's foolproof. You have a calculator. You don't have to memorize it. Just try it. When you square root that thing, it gives you 10 minus y, 10 plus y. Awesome. D. D was a little trickier because there's all those coefficients and all those letters in there. But we're still going to follow the same rules. Can you GCF this thing? The answer is no. You can't. You could try, but you can't find something. You count it as 2 terms. It's a subtraction question. That's wonderful. Then you look at it and you say, can I square root everything? Can I square root 36? Check in your calculator. Yes. P squared is even. Can I square root 25? Yes. Can I square root q squared? It's even. Yes. This is a difference of squares. It's just a complex one. So when you square root every individual thing, the square root of 36 is 6. Square root of p squared is p. Minus square root of 25 is 5. Square root of q squared is q. 6p minus 5p. The second binomial is the exact same thing, just with a plus sign. There you go. I want to do D or E and F with you because they're a little bit different. We're going to look at E. First step is GCF. Second step is to count the terms after that. Okay, we counted there's 2 terms here. People look at that, they go, I can square root 4, x squared 25, and they do difference of squares. The problem is, that's not a difference of squares. Difference of squares is subtraction only, right? Difference, not addition of squares. This thing, because of the plus sign, is not a difference of squares. That means it cannot be factored. So the answer would still be 4x squared plus 2. And people just get so into the habit of squaring everything that they just kind of forget. They forget to check, right? And they just start doing what they think they're supposed to do. Awesome. F is a little weird because there's extra letters on one of them. So if you look at F, it still fits our rule. It's subtraction. That's good. I can square root everything. 64 square roots, 9 square roots, 8 squared square roots, and b squared square roots. So I can do one big difference of squares here. Square root of 64 is 8 minus 3. Square root of a squared is a. Square root of b squared is b. The next answer is going to be the same thing, but with a plus symbol. It's a little different looking, that's all. Okay, it gets a little bit harder than that. So, let's Still going to follow the same rules, just going to get a little trickier. Slide down to class example number 4. So the thing that makes these a little trickier is there will be a GCF. Okay, so if we look at question A, the question says factor. Let's pretend it's a test question. All it says is factor. My first step is remove a GCF. A GCF being a number or letter that can divide into every term. If I look at this, I could divide both of these by 2. Correct? That means 2 goes out front. That's my GCF. And whatever's left over goes inside the brackets. 2a squared divided by 2 would be a squared. 50 divided by 2 would be 25. So that thing has a GCF of 2 with a remainder of a squared minus 25. Does that ring a bell from way back in GCFing? That's like almost 2 weeks ago. Good. After you GCF, you count the terms in your remainder. Looking at the yellow thing here, I have 2 terms. 2 terms means difference of squares. Is this a difference of squares? Yeah, I can square root a squared, I can square root 25, and it's a subtraction question. So I square root everything. Notice that you're only square rooting the remainder, right? The GCF was its own thing out front. So the GCF is still out front. When I square root this, it becomes a minus 5, a plus. That's about as hard as it's going to get when it comes to difference of squares. Remove a GCF first, then do difference of squares. Awesome. If you look at B, first step to factor is take a GCF out. Again, you can take a GCF out of this one. I can take a 3 out of both terms. When I do that, it gives me 3 on the outside as my greatest point factor, and I get a leftover of x squared minus 4y squared. And again, I'm left with a binomial that is a subtraction question that is all perfect square terms. That means I can square root and use difference of squares. My GCF is still out front. My remainder is x minus 2y, x plus 2y. Fantastic. Go ahead and try C and D on your own. C is a little tricky because it is a difference of squares right now. However, there is a GCF there. So you should take the GCF out first. Alright, so go ahead and try C and D. Okay, so the GCFs are both up there. They are both difference of squares when you're done. So if you look at the first one, which is part C, 36 is square rootable, p squared is square rootable, q squared is square rootable, and 1 is square rootable. And it's a subtraction, right? So you always want to make sure it's subtraction. That gives me a final answer of 4 on the outside. The GCF is still there, don't lose it. That happens every once in a while. 6p q minus 1, 6p cubed plus 1. That would be my difference of squares. The very last one, again, I took out a 3x, so I GCF that out. After I do that, I look at what's left over and I square root it because it was a difference of squares. The 3x remains out front, so 3x. And then I get x minus 3, x plus Here's the thing about factoring is like if you don't practice a variation of questions, a variety of questions, that's a better word. Like if you don't go and like mix it up every once in a while, you're gonna have a hard time when it comes to a test or a quiz. Because you're just gonna get a question that says factor and you're gonna be like, whoa, which strategy do I use? Right? And we have 5 different factoring strategies out there. So my suggestion is that you do mix it up on which assignments you're doing. Right? Go back, see if you remember how to do grouping method. Right? Go forward, see if you can do difference of squares. Go try a couple trinomials. Like test things out and make sure you have them all. Right? There is an assignment a little bit further on. So there's difference of squares assignment for today, which would be a great thing to work on right now. But then there is like a practice test and a little factoring review assignment. Probably a good idea to try to get to that tonight. Awesome.